Okay, guys, here is your 4-1 to 4-5 test review for your test on Friday. Please, everybody be there on Friday. The stuff you need to know from 4-1 and 4-2, right? We have got to know the difference between exponential functions and between logarithmic functions. Some of you will get an exponential function. You'll get the equation that might say like f of x equals, 3 to the x plus 1 minus 4. And they're going to ask you all this stuff. They're going to say, what's the domain? Well, the domain for every exponential is negative infinity to positive infinity. Your range is going to be based upon your horizontal asymptote. Remember, your horizontal asymptote is whatever is being added or subtracted. So your horizontal asymptote for this question would be at y equals negative 4. So your range would be based upon that. So think about range like this. Is this a positive exponential function or a negative one? It's a positive one, so it's going to go like this. So you have an asymptote here at negative 4. So does your function exist down here from negative infinity to negative 4 or from negative 4 to positive infinity? So your range would be from negative 4 to positive infinity. And then if you were asked to find the y-intercept, you would plug in 0 right here for x. So if I plugged in 0 for x, 3 to the 0 power, 0 plus 1, 3 to the first power is 3 minus 4. So your y-intercept, where it crosses the y-axis, when I plug in 0 for x, I get negative 1. So it would be at when x is 0, y is negative 1. You have to put it as an ordered pair. So if I come over here to a logarithmic function, okay, guys, logs are ln, it'll be written like this, like f of x equals log base 2 of, x plus 4, right? So in this case, for logs and natural logs, your range is always the negative infinity to positive infinity. Your domain and your horizontal asymptote are based upon each other. And the way that you figure that out is you set the parenthesis equal to 0. So if I say x plus 4 equals 0, I'm going to subtract 4 from both sides, so I get x equals negative 4. So that means my vertical asymptote here would be at x equals negative 4. And it's a positive, so that means it's going to look like this. Negative 4 is my asymptote, and my log goes like that. So that means your domain is from negative 4 to infinity. It does not include negative 4. Now, if you're trying to find the x-intercept, remember we plug in 0 for y. So I'd have log base 2 of x plus 4 equals 0. So guys, we've already learned this. What's the opposite of logs? Exponentials. So I have a big 2, and then I write log 2 x plus 4 equals big 2 to the 0 power. Well, 2 log 2 will cancel out. X plus 4 equals 2 to the 0 power is 1. Subtract 4 from both sides, and x equals negative 3. So your x-intercept, your x-intercept is going to be at the ordered pair when x is negative 3, y is 0. All right, so each version will have one of those types of questions, not both. You will also have on every version one of these lovely interest problems. We have 2 interest formulas. We have this one over here, which talks about interest that's compounded a certain way, like monthly, daily, something like that. But P is your principal. It's the amount that you start off with. Remember, your R has to be as a decimal. N is how the money is compounded. And T is your time in years. So annually, your N would be 1. Semi-annually, it's 2. Quarterly, it's 4. Monthly, it's 12. Daily, it's 365. When you have a function, or when you have an amount of money that says continuously, that's when we use a per. That's when your principal, it's still the same thing. Principal is the original amount. R is your rate, got to be as a decimal, and T is in time. But you don't have any N, so you use this formula called a per. But that's what you guys need to know from 4-1 to 4-3. Now when we get here, all right, I'm gonna go through all of these to make sure we understand. This first section, and the directions are written on your study guide that you guys had, but they're asking you to use the change of base formula. Remember, the change of base is log of the number over log of the little base, or the little log number, whatever you want to say. So you would write this as log 4 divided by log 7. This is how you would show work. And in your calculator, you literally hit log 4, close your parenthesis, divided by log 7. And I'll tell you what to round to. But here I get 0.7124. We'll round to 4 decimal places. So in this case, you'd have log 64, log of the number, divided by log of that little base. So look, 1 divided by 8. So in your calculator, you hit log 64, close your parenthesis, divided by log, and you need to put 1 divided by 8 in its own parenthesis, so you're telling your calculator that it's a fraction. But in this case, I get -2. So here, number 18, I have log, it would be log of 0.045 divided by log 4. So I have log 0.045 divided by log 4 in my calculator, and I got -2.23, we'll say 70, the way that rounds. And then on 20, I'd have log of 175, log of the big number, divided by log of the little base. So log 175 divided by log 20. And I got 1.7240. So that's how you would solve a problem or anything like that where you had to use a change of base formula. On these ones over here, they're asking you to expand and condense. It'll tell you, all the ones in blue, it'll tell you to expand or condense. I'm not going to make you wonder what to do, but if you look at it, you should be able to tell. Remember, the things that are most important to remember is that multiplication goes with addition, division goes with subtraction, and coefficients go with exponents. Coefficients, I think I spelled it right, go with exponents. If you guys can remember that when you're pulling apart and smushing together, you should be okay. So in this case, the directions would tell you to expand. If you notice, you have a 10 times z. There's a multiplication in the middle there. When you have multiplication and you're pulling apart, what do you think of? Addition. So when you are pulling things apart, each piece gets its own log, or ln. So this would be log 10, log little 10 of 10, plus log little 10 of z. And then you simplify if you can. Log 10 of 10 is just the number 1, plus log 10 of z. Now, if it just said log and there was no number, you assume that it's a little 10 there. It's log base 10. But there's your answer. So in this case, I look and I say, okay, I have log 10 of 7 divided by x. Well, when I see division and I'm pulling apart, I think subtraction. So each piece gets its own log. So I have log 10 of 7 minus log 10 of x. And that's it. All right, I come to 52 and I look and I say, okay, I have log 6z -3. Where is the -3? Coefficients become what? Exponents, and exponents become coefficients. So this exponent is going to become a coefficient. It's going to come in the front. So I'm going to bring that down the front. I have -3 log 6 of z. That's it. Right here I have ln. If you guys are, if you see this written and you're like, okay, wait, I can write this another way. Remember, square root is the same as an exponent of 1/2. Cube root is the same as an exponent of 1/3. Fourth root, exponent of 1/4. Same thing. So I'm going to rewrite this first as the ln of t to the 1/3. And then I realize, oh, my exponent becomes a coefficient. So this is the 1/3 ln of t. And that's it. So again, here I look and I say, okay, there's a lot going on. I see an x, a y, and a z. There's 3 things. These 2 are being multiplied, so that means I'm going to add here. And this is a division, which means I'm going to subtract here. So I'm going to write ln 3 times because there's 3 different letters. So I say ln of x plus ln of y. And then I have subtract ln of z. Just pull it apart. All right, again, I'm looking at this. I see log 4, x times y times z. So everywhere I see a multiplication, I know when I pull it apart, I'm going to have to add. And then I see here exponents. Those become what? Coefficients. So the first thing I'm going to do is I'm going to say log little 4 of x plus log little 4 of y to the 6th plus log little 4 of z to the 4th. Now, some of you will skip that step and not do it, which is fine, but you have to show me that these exponents then become coefficients. So to fully expand this logarithm, it's log 4x plus 6 log 4 of y plus 4 log 4 of z. Everything should be written linearly on one line. All right, here I see a big square root, so I'm going to rewrite this as the natural log of x squared over y cubed, and it's to the 1/2 power. So there's a lot going on here. I see an exponent that's going to become coefficient. Then I see exponents inside my parentheses that'll become coefficients. And I also see a division, which will become a subtraction. So just take it piece by piece. I'm going to rewrite that 1/2. I'm going to bring that out in front. And then I have the natural log of x squared minus the natural log of y cubed. Then those become coefficients. So it's 1/2 to natural log x minus 3 natural log of y. All right. Now these are already pulled apart. That means I have to smush them together. So I notice I have the same log or natural log, ln. This addition is going to change to multiplication when I smush them together. So I rewrite ln one time, and then I have y times z. You can write a multiplication sign in the middle if you want to. You don't have to. I'm just saying that you guys can if you wanted to. So here I see subtraction, and I think, ooh, subtraction becomes division. They both had the same log base, so I write log 5 one time. And just how you read it is how you write it. So it would be 8 divided by t. All right, looking at this, I see, oh, it's a coefficient. Coefficients become exponents. You can't separate z minus 4 because it's in parentheses, so this just becomes log 7 of z minus 4 to the 5 over 2. And I can simplify that a little more. I can rewrite this as log base 7. This 2 becomes the root, so it's the square root of z minus 4 to the 5th power. That'll be a little more simplified. Here, again, I see coefficients are going to become exponents. I have one natural log, so I rewrite natural log one time. I have x squared times x plus 1. All right. Again, I see a coefficient. It's going to become an exponent. I write natural log one time. This is going to become an exponent here. So, and then this becomes division. So I have x divided by, and then x plus 2 squared. Over here, this is a big long one, but that's okay. I see a coefficient that's going to become an exponent, a coefficient that becomes an exponent, a coefficient that becomes an exponent. I see addition, which is going to become multiplication, and I see subtraction, which is going to become division. So I'm going to write ln one time out in front, and I have x cubed times y squared divided by z to the 4th. And again, you just write the ln one time. It's just out in front, not in the numerator or the denominator. All right, now guys, when you're solving, when you have an equal sign and you're solving, you're going to solve and check. You need to check for extraneous solutions, ones that don't work. All right, got to make sure that you don't have to show me a formal check. You don't have to do anything other than plug it in your calculator and just make sure. Another thing you have to remember is that you cannot take the log or ln of a negative. So you got to check for that too, okay? So when we attack these problems, the first thing I tell you guys that you should do is to isolate your function. So this is an exponential function. When I think about exponentials, I think the opposite is logarithmic. There's nothing being added to, subtracted, nothing to this 3 to the x. So I'm going to think, okay, I have to get that 3 to go away. So what's the opposite of big base 3? Log base 3, log little 3. So log 3 of 3 to the x, what you do to one side, you do to the other. So this becomes log 3 of 243. So on the left-hand side, log 3 of 3 cancels. You're left with x. And in your calculator here, you would do log of 243 divided by log 3. Now, guys, I need to see all of your work. So I need to see that you understand you need to put in your calculator log 243 divided by log 3. If all you do is just have things written out nice and beautifully neat because you copied it off of Mathway, I promise you I'm not going to give you any credit. I promise. So then 2 seconds, guys, you take 5, you plug it in here, and you see if 3 to the 5th power equals 343, or 243, I'm sorry, which it does. So now I'm moving along here. Same thing. I have an exponential function, so my logarithmic is going to be the inverse. There's nothing being added to or subtracted, so I'm going to say log, and I'm going to use a little 7, so I can rewrite this as 7 to the x, and it crosses out. What you do to one side, you do to the other. So I have log little 7 of 1 over 49. Log 7 cancels out. I have x equals. In your calculator, it's log 1 over 49 divided by log 7. Show me that you understand that that's what you're doing in your calculator. So log, and then in parentheses, I'm going to put 1 divided by 49, close my parenthesis, divided by log 7. And I get negative 2. Take that negative 2, plug it in there. 7 to the negative 2 power is 149. You're good to go. All right, same thing here. Exponential, opposites logarithmic. So I'm going to say log. My little base is going to be 1/2. So then I have 1/2 to the x. What you do to one side, you do to the other. So log little 1/2 equals 32. Log 1/2 cancels out. So I have x equals. My calculator, I'm going to type in log 32 divided by log of 1/2. So log 32 divided by log 1 divided by 2. And I got negative 5. So you would take that negative 5, plug it in here. 1/2 to the negative 5th power equals 32. Same kind of problem, all right? I'm going to say log my little 3/4, and then I have 3/4 of the x equals log little 3/4 of 27 over 64. Guys, fractions are no big deal. Cross these out, you get x equals. In your calculator, it's log, and you would do 27 divided by 64 divided by log of 3 over 4. So log 27 divided by 64, and then I have divided by log 3 divided by 4. And I got 3. X equals 3. So plug that in there. You're good to go. All right. Now we have something that looks a little different. Again, we need to make sure that we check and to make sure. But I have e to the x equals 66. E to the x and ln are inverses of each other. They're on the same button on the calculator. So if I have e to the x equals 66, I want to get that e to go away. So I'm going to say ln, e to the x on the left-hand side. That means I have to take the ln of 66. ln and e cancel out. So in your calculator, hit ln 66 and hit enter. And you get 4.1896. So we'll say 90. Take this number, plug it in here, and you should get something really close to 66. We do, so we're good to go. I will tell you guys what to round to, so make sure you're paying attention to that. But as these problems get a little more involved, a little more difficult, again, it's nothing you guys can't handle. You just have to take your time and follow the steps. First thing I'm going to do is isolate. This is an exponential function. That means my inverse would be a logarithmic. So the first thing I have to do is get this exponential by itself because it's not. So I'm going to have to divide both sides by 5. So I have 8 to the x equals 325 divided by 5, which is 65. Right? So now that I have my exponential by itself, I say, okay, the opposite of exponential is log. So I'm going to say log, and I'm going to use a little 8 because I want the big 8 to cancel out. What you do to one side, you do to the other. So 8 log 8 cancels. Now in your calculator, guys, change your base formula. You do log of the number 64 divided by log of that little base. Do that in your calculator, and we get log 64 divided by log 8. I get 2. Take that, plug it in here, and you should get something real close to 325. All right, coming here again. My exponential is all by itself. It's just hanging out here. I don't have anything being added or subtracted. So I have to use my inverse. Inverse of log is going to be inverse of exponential is going to be log. So I'm going to say log, and I'm going to use a little 3 because my big base of 3 here will cancel out. What you do to one side, you do to the other. So it's log little 3 of 1 over 81. These cancel out. You have x minus 1 equals. In your calculator, you'll do log of 1 over 81, log of the number, divided by log of the little base. Again, I need to see all of these steps in order for you to receive credit on your questions that you complete. So 1 divided by 81, close my parenthesis, divided by log 3. And I got negative 4. So x minus 1 equals negative 4. I'm going to add 1 to both sides, and I get x equals negative 3. We take x equals negative 3, we plug it in here, and we make sure that that equals 1 over 81. All right, now I have these two, and I'm like, how do I do this? I have 2 natural logs. Well, think about it. We learn how to pull logs apart and to pull them together. So when I look at this and I want to solve it, I have to have 1 natural log together. Since they both have an ln, I see this subtraction sign. I know that I can change that to division. So I'm going to rewrite this as the natural log of x over 2, and that equals 0. Now that I see that my natural log is completely alone, I know that e to the x and ln are inverses of each other. So I'm going to say e to the ln x over 2 equals e, which you do to one side, you do to the other, to the 0. So e and ln cancel out. I have x over 2 equals e to the 0 power is 1. Multiply both sides by 2, and I get x equals 2. So now we have to check. I got to take this because you cannot take the natural log of a negative number. So when I plug this in right here, natural log of 2, that's not negative, we're good to go. If I had the natural log of 2 minus the natural log of 2, I get 0. So we are correct. All right, come to this problem. I have a natural log. What's the opposite of natural log? E. My natural log is all by itself, so I'm going to say e to the ln x into the exponent. What you do to one side, you do to the other. So I get e to the negative 14. E and ln cancel out. I get x equals e to the negative 14th power, which is 0.0000 6 6 zeros 8 2. Now what do I have to do? I need to plug that in here and make sure I get the correct answer. All right, scooting along. Now I see, okay, I have a logarithmic. Well, think about logs. Oh, what do I do with a log? What's the opposite of a log? It's going to be exponential. So I use the little base. That's going to become my big base. So I have x, and then everything goes to the exponent. And then if I have that on one side, then I put x to the second power on this side. So look, my x log x cancels out. I have 25 equals x squared. Square root both sides. X equals plus or minus 5. Now, before you move on, guys, you have to go back and look. Can I put 5 here and this works? Can I have log base 5? Absolutely. So x equals 5. Can I take negative 5 and put this as log base negative 5? No, you cannot. So you only have one solution here, and it's x equals positive 5. The other one is extraneous. All right, logarithmic. Opposite of logarithmic is exponential. I don't have anything being added, subtracted, anything like that. So I'm going to use this little base and make it my big base. So 10 to the log 10 to the x equals 10 to the negative 1/2. So that crosses out. You get x equals. Guys, when you put this in your calculator, when you put that caret button in, you need to put -1 divided by 2 in parentheses. Make sure you guys do that. So we have 10, and I raise that to the -1/2 power. And I get x equals 0.3162. Now I would take this and I would plug it in right there, and I make sure I'm not taking the log of a negative number, and I'm not. All right, scooting along, scooting along. You guys are doing a good job. I have natural log here. Nothing's being added or subtracted, anything, so opposite of natural log is e. So I have a big E, and I'm going to write natural log 3x plus 5 equals e to the 8th power. These two cancel out, so I'm left with 3x plus 5 equals, well, e to the 8th is 2980.958, we'll say. Now we solve an equation like we normally would. We're going to subtract 5 from both sides. So you get 3x equals, what was it, -5? 2975.958. Divide both sides by 3. And x equals 991.986. And I take that, I plug it in here. If I put 991.986 times 3 and add 5 to it, I will have a positive number. So I'm good to go. All right, if we're just asked to simplify, these are just two real basic questions. E and ln cancel out here, so you're left with 2x minus 1. Here, e and ln cancel out, so you're left with x squared plus 2. Just a little simplifying to remind yourselves. Here, guys, I'm starting with the natural log. What's the opposite of natural log? E. So I'm going to say e ln x equals e to the -4. E and ln cancel. I get x equals e to the -4 power. Gives me 0.0183. Take that, plug it in, see what you get. It works. So now I come here and I say, okay, ln 2x. Guys, I cannot, if the 2 was out in front here, I would divide both sides by, if it was out in front here, I would divide both sides by 2. But it's not. It's stuck in between the x and the natural log. So I'm just going to say opposite of natural log is e. So e to the ln 2x equals e to the 1.5 power. E and ln cancel out. You have 2x equals e to the 1.5 power. So second e, 1.5, gives me 4.482. Divide both sides by 2. And x equals 2.241. Take that, plug it in here, make sure it works. It cannot be negative. Make sure you pay attention to that. All right, when it gets to something like 96, 96 is pretty cool. It's I don't know if you guys would say cool, but you know what I mean. What do you notice? You have one log on one side and one on the other, and you notice that both of those logs have the same little base, they're both log base 9. Which means if they had the same log, you can just cross them out. So now solve. 4 plus x equals 2x minus 1. I'm going to move x here. I'm going to add 1. And I get that x equals 5. All right, now I have to check to make sure that when I plug 5 in, it does not make the log negative. So when I plug in here, 4 plus 5 is 9. Okay, we're good. When I plug in here, 2 times 5 is 10 minus 1 is 9. So x minus 5 is a viable option. If you guys plug it back in and it makes the log or natural log negative, your answer is no solution. All right, in this case, guys, look here. Here is my function, natural log of x. I have something being added to and multiplied by. So you've got to get this by itself first. So the first thing you're going to do is subtract 3. So you have 2 natural log x equals 7. Now we're going to divide by 2. So I have the natural log of x equals 7 over 2. Opposite of natural log is e. So I have e to the ln x equals e to the 7 over 2. in your calculators, this is going to be x equals, you need to hit E, the caret, and then 7 divided by 2 in parentheses. When we do that, we get e to the 7 divided by 2 power. I get x equals 33.115. And now I would take this and I say, okay, when I plug in 33.115, is that going to make my log or natural log negative? No, it's not. We're good to go. Okay, so coming to this one, I see 4 times log base 10, x minus 6 equals 11. Okay, this is what we need to isolate. We've got to get it by itself. So I'm going to divide both sides by 4. And I'm going to say log base 10 of x minus 6 equals 11 over 4. Now the opposite of logarithmic is exponential. So I'm going to use this little 10. This is going to be my guideline. It's going to be a big 10 base. Everything goes upstairs. What you do to one side, you do to the other. So I have 10 to the 11 divided by 4 power. So 10 log 10 cancels. You get x minus 6 equals. Y'all, in your calculator, this needs to say 10. When you hit the caret button, it needs to be 11 divided by 4 in parentheses. So when I do that, I get 562.341. Now I'm going to add 6 to both sides because I want to get x all by itself. And I get 568.341. Take that value, plug it in here for x. Make sure that the parentheses value does not become negative, because if it does, then this is not a solution here. It should be no solution. All right, couple more. We're almost done. When I get to this question, I see log 10 x squared equals 6, okay? I cannot separate the x squared, can't take square root, anything like that. I have to say, okay, the opposite of log is exponential, so 10 log 10, x squared's up here. X squared equals 10 to the 6th power. So this cancels. I get x squared equals, it's going to be 1,000,000. I got 6 zeros. And then I have to take the square root. Guys, when I take the square root, I get x equals plus or minus 1,000. Now, when I have positive 1,000, all right, if I plug in positive 1,000 here and I square it, we're good to go. So x equals 1,000. If I take negative and I plug it in, negative times a negative is a positive, so x could equal negative 1,000 as well. You've got to check to make sure that everything works. In this case here, natural log is all by itself. What's the opposite of natural log? E. So I have e and then ln square root x minus 8 equals e to the 5th power. E and ln cancel, so I have the square root of x minus 8 equals e to the 5th power. 148, and then we'll say 0.413. So now, guys, in order to get the square roots go away, you got to square both sides. Doesn't matter that's a crazy decimal. That's no worries. So I get x minus 8 equals, I'm going to square this side. Oh, I took the square root. Whoops. So 148.413 squared. I get 22,26 we'll say 419. And now I need to get x by itself, so I'm going to add 8 to both sides. So add 8, and I get x equals 22,034.419. Take that value, put it in here. Make sure it does not make the log or natural log a negative number. We're good. Same thing here. Opposite of ln is e. So I have e. Everything goes upstairs. X squared plus 1 equals e to the 8th. That crosses out. You have x squared plus 1 equals e to the 8th. 2980.958. So I'm going to subtract 1 from both sides. X squared equals 2979.958. Guys, square root. When I take the square root, I get x equals plus or minus. Remember, plus or minus 54.59. If I take positive 54.59 and plug it in here, and I square it, positive value, good to go. If I take x equals negative 54.59, plug it in here, square it, positive answer, we're good to go. Always, 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 guys, you've got to check. All right, we come to something like this. Looks like this is like a factoring problem. All right, because I have e to the 2x and I have e to the x. So it's very important that you guys understand that this is a quadratic. You use your algebra skills like you would if you were just factoring a quadratic. What are the factors of negative 24? That multiply to give me negative 24, but add to give me 2. Well, it's going to be positive 6, negative 4. So I'm going to say e to the x plus 6, e to the x minus 4. We're going to solve each of these equations independently, and we're going to get answers. I'm going to subtract 6 from both sides. So I have e to the x equals negative 6, and I'm going to add 4 to both sides, so I get e to the x equals 4. Guys, the opposite of e is ln, so take natural log of one side, you got to do it to the other. When you hit natural log of negative 6 in your calculator, you get an error message because you cannot take the natural log of a negative number. So this is an extraneous solution. It does not count. If I take the natural log here, the natural log here, I get x equals, and in my calculator, I'm going to say natural log of 4, and it's 1.386. Take that, plug it in, and make sure it works. In this case, same thing, just a is not 1. So you have e to the x, e to the x. Now we're going to say 2 times negative 15 is negative 30. What are the factors of negative 30 that multiply to give me negative 30 but add to give me 7? It's going to be positive 10 and minus 3. My a term is not 1, so you're going to divide both factors by 2. So I have e to the x plus 5 equals 0. And I have 2 e to the x minus 3 equals 0. And now we solve like we normally would. We're going to subtract 5 from both sides, so I get e to the x equals negative 5. Here I'm going to add 3 to e to the x equals 3, divide by 2, and I get e to the x equals 3 over 2. So, to solve, take the natural log. If I take the natural log of one side, I do it to the other. When I take the natural log of negative 5, my calculator tells me it's an error. It's because you can't take the natural log of a negative number, so this is an extraneous solution. In this case, I'm going to take the natural log of both sides, so x equals, and I hit ln, and then 3 divided by 2, and I get 0.405. Take that, plug it in up here, and make sure it works. Okay, for those of you who made it to the end, congratulations. It's very smart of you to pay attention and follow along. Here's a little bonus question. All right, if you came to a problem like this, you might see something like this on your test. This is important that you understand how to do this. Before you can use inverse operation, do you have to have just one log together? So if you notice here, you have log 3 and log 3. They're the same log, and we've learned how to condense, how to put logs together. This subtraction would become division. All right, so I can rewrite this. I can smush this together and just write 1 log 3, and then I'd have x over x plus 4 equals 7. Now, this is a problem that you guys can solve very easily. Since you know properties of logs and inverses and stuff like that, the opposite of log base 3 would be exponential with a big base of 3. So I'm going to say 3, and then everything else is just going to go up here in the exponent. And what you do to one side, you do to the other. So I have 3 to the 7th power. So 3 log 3 would cancel out. That leaves me with x over x plus 4 equals, and what is 3 to the 7th power? 3, it's a big number, to the 7th power. Oh, not too big. 2,187. Now we solve a simple equation, right? This is over 1. So if you were going to multiply fractions or trying to solve a proportion, you'd multiply, cross multiply. So 2187 times x plus 4 equals x. Distribute this in here. So you get 2187x plus, what's 2187 times 4? 87.48. The value of these numbers doesn't really matter. I just made this up as I was sitting here. So now I'm going to move everything. I'm going to move this to the other side. And I get negative 2186x equals 8748. I would divide both sides by negative 2186. Again, this is a huge gross number, but it just worked out that way. So x equals, if I divide this by negative 2186, I get negative 4.0018. Right? So now I look at this and I say, okay, if I take this number and I plug it in up here, will it make my problem or my log negative? So I'd have negative, we'll say negative 4. It's kind of close to negative 4. So I have log 3 of negative 4 over, or we can plug it back in. Let's just do it right here. If I plug it in right here, can I take log 3 of a negative number? No. Can I take log 3 of a negative number when I plug it in here? So even though I got an answer, right? I condensed everything together. I solved like I normally would, and I got an answer of x equals negative 4 point blah, 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 whatever. This answer does not satisfy my equation because when I plug it back in, it makes the original log negative. So your answer here, guys, would be no solution. If you come to one on your test that when you plug it back in, it makes the log or the natural log or something negative, your answer is no solution. Even though you came up with x equals something, your answer is no solution. I cannot express that or impress that upon you enough. All right, so I'm going to upload this now, guys. If you have any questions, I cannot answer emails tomorrow during the day, but I can in the evening, in the afternoon, that sort of thing. So shoot me an email. But you should be well prepared. You've had plenty of time to ask questions and go over things, so make sure you watch this video.